Today we are traveling to each planet in our solar system to uncover some fascinating facts about each one. Thank you for watching and enjoy. We will start with the closest planet to the Sun, Mercury. Mercury is also the smallest planet in our solar system, just slightly larger than Earth's moon. Despite its size, it packs a punch with its unique characteristics. For instance, if you stood on Mercury, you'd weigh only 38% of your Earth weight due to its lower gravity. Unlike Earth, Mercury doesn't have a substantial atmosphere. Instead, it has a thin exosphere composed of atoms blasted off its surface by the solar wind and micrometeoroid impacts. This exosphere contains oxygen, sodium, hydrogen, helium, and potassium. Mercury's surface temperatures are extreme. During the day, temperatures can soar to 430 degrees Celsius, or 800 degrees Fahrenheit, while at night, they can plummet to minus 180 degrees Celsius, or minus 290 degrees Fahrenheit. This drastic fluctuation is due to the lack of a significant atmosphere to retain heat. Mercury's orbit is another marvel. It has the most eccentric orbit of all the planets, meaning its distance from the Sun varies greatly. This elliptical path takes Mercury as close as 47 million kilometers, or 29 million miles, and as far as 70 million kilometers, or 43 million miles from the Sun. Despite its small size, Mercury has a magnetic field, albeit much weaker than Earth's, at about 1.1% of the strength of our home planet. This magnetic field is generated by a partially molten core, making Mercury the only other terrestrial-type planet, besides Earth, with a global magnetic field. Mercury's surface showcases its violent past. It's covered with craters from impacts that date back billions of years. One of the most notable features is the Caloris Basin, a massive impact crater about 1,525 kilometers, or 950 miles in diameter. This colossal scar was likely formed by an asteroid impact many years ago. Now here's a surprising fact. Mercury has ice. In the permanently shadowed craters at its poles, temperatures remain well below freezing, cold enough to preserve water ice. This discovery was made by NASA's Messenger mission, which found evidence of ice deposits in these shadowed regions. So as we gaze at Mercury, we see a planet of contrasts, extreme temperatures, a thin exosphere, ice in shadowed craters, and a magnetic field. It's a world that, despite its proximity to the Sun, holds many secrets waiting to be uncovered. Our next stop on this interplanetary adventure is Venus, the second planet from the Sun. Venus, often called Earth's twin, is similar in size and structure to our home planet. But don't let that fool you. Venus is a world of extremes and mysteries. One of the most striking features of Venus is its atmosphere. It's incredibly thick, composed mainly of carbon dioxide, with clouds of sulfuric acid. This dense atmosphere creates a runaway greenhouse effect, making Venus the hottest planet in our solar system, with surface temperatures reaching a scorching 464 degrees Celsius, or 867 degrees Fahrenheit. Here's a strange fact. A day on Venus is longer than its year. Venus takes about 243 Earth days to complete one rotation on its axis, but only 225 Earth days to orbit the Sun, and it rotates in the opposite direction of most planets, meaning the Sun rises in the west and sets in the east. Venus's surface is a volcanic wonderland. It's dotted with over 1,600 major volcanoes, and while most are dormant, some may still be active. The planet's surface is relatively young, geologically speaking, with vast plains of solidified lava. High above the surface, in the upper atmosphere, temperatures range from 30 to 70 degrees Celsius, or 86 to 158 degrees Fahrenheit, which could potentially accommodate Earth-like extremophile microbes. This has led some scientists to speculate about the possibility of microbial life in Venus's clouds. although many say it's not likely. Venus is also known as the morning star and the evening star. Early civilizations thought Venus was two different bodies. These were called Phosphorus and Hesperus by the Greeks, and Lucifer and Vesper by the Romans. The atmospheric pressure on Venus is over 90 times greater than Earth's. This crushing pressure means that small asteroids burn up before reaching the surface, resulting in fewer small craters compared to the other planets. This also means that anyone or anything trying to land on its surface would likely be crushed and burned by the extreme conditions on Venus. So as we gaze at Venus, we see a planet of extremes, scorching temperatures, crushing pressures, and a thick, toxic atmosphere. It's a world that, despite its harsh conditions, continues to intrigue scientists and spark curiosity. Our next stop is Earth, the third planet from the Sun and our home. Earth is unique in many ways. It's the only planet known to support life, thanks to its perfect combination of atmosphere, water, and temperature. About 71% of Earth's surface is covered by water, making it a planet of oceans. These vast oceans are crucial for regulating the planet's climate and supporting a diverse range of life forms. One of the most fascinating aspects of Earth is its atmosphere, composed mainly of nitrogen at 78% and oxygen at 21%, with trace amounts of other gases. It provides the air we breathe and protects us from harmful solar radiation. The atmosphere also creates weather patterns and helps maintain a stable climate. Earth's magnetic field is another remarkable feature, generated by the movement of molten iron in its core. This magnetic field shields us from the solar wind, a stream of charged particles from the sun. Without this protection, life as we know it would be impossible. Our planet has a dynamic surface, constantly reshaped by geological processes. Plate tectonics cause continents to drift, mountains to rise, and earthquakes to occur. This activity also leads to the formation of volcanoes, which play a vital role in recycling Earth's materials and gases. Earth's rotation and orbit are perfect for supporting life as we know it. A day on Earth lasts about 24 hours, and it takes 365.25 days to complete one orbit around the Sun. This extra quarter of a day is why we have a leap year every 4 years. Earth is the only planet in our solar system not named after a Greek or Roman deity. Its name comes from Old English and Germanic, meaning the ground. This reflects our deep connection to the land we live on. So as we look at Earth, we see a planet of water, life, and dynamic processes. It's a world that continues to inspire and sustain us, reminding us of the delicate balance that makes life possible. Our next destination is Mars, the fourth planet from the Sun, and a world that has fascinated humanity for centuries. Mars, often called the red planet, gets its distinctive color from iron oxide or rust on its surface. But there's so much more to Mars than its reddish hue. Mars is home to the largest volcano in the solar system, Olympus Mons. This colossal shield volcano stands about 22 kilometers, or 13.6 miles high, nearly 3 times the height of Mount Everest, and spans 600 kilometers, 373 miles in diameter. Another remarkable feature of Mars is Valles Marineris, a vast canyon system that stretches over 4,000 kilometers, or 2,500 miles long, 200 kilometers, or 120 miles wide, and reaches depths up to 7 kilometers, or 4.3 miles. It's around 10 times longer, 20 times wider, and 5 times deeper than Earth's Grand Canyon. Mars has 2 small moons, Phobos and Deimos. These irregularly shaped moons are thought to be captured asteroids from the nearby asteroid belt during the formation of the solar system. One of the most intriguing aspects of Mars is its past. Evidence suggests that Mars once had liquid water on its surface. Ancient river valleys, lake beds, and minerals that form in water all point to a wetter, warmer past. This begs the question, Could Mars once have been much more Earth-like in its past? And could it have contained life? These are questions scientists are still working to answer. Mars's atmosphere is thin, composed mostly of carbon dioxide, with traces of nitrogen and argon, with small amounts of other gases. This thin atmosphere is due to solar wind and radiation from the sun that have stripped away the planet's atmosphere over the years. Due to the presence of dust in its thin atmosphere, it allows for some stunning phenomena, like beautiful blue sunsets. Mars is also the only planet we know of that is inhabited entirely by robots. NASA's rovers, like Curiosity and Perseverance, are exploring the Martian surface, searching for signs of past life and preparing for future human missions. Despite its harsh conditions, Mars has seasons, polar ice caps, and weather patterns similar to Earth. The Martian year is about 687 Earth days, and a day on Mars is just slightly longer than an Earth day, at 24.6 hours. So as we look at Mars, we see a planet of towering volcanoes, vast canyons, and a history that hints at a once more hospitable world. Our next stop is Jupiter, the fifth planet from the Sun, and the largest in our solar system. Jupiter is another world of extremes. This gas giant is so massive that over 1,300 Earths could fit inside it. Despite its size, Jupiter has the shortest day of all the planets, taking just under 10 hours to complete one rotation. One of Jupiter's most iconic features is the Great Red Spot, a giant storm larger than Earth that has been raging for hundreds of years or more. This colossal storm is a high-pressure region where winds can reach speeds of about 432 kilometers per hour, or 268 miles per hour. Jupiter is also known for its stunning cloud bands, which are made up of ammonia and water, floating in an atmosphere of hydrogen and helium. These bands flow in opposite directions, creating the planet's distinctive striped appearance. Jupiter has a faint ring system, discovered in 1979 by the Voyager 1 spacecraft. Unlike Saturn's bright rings, Jupiter's rings are made of small, dark particles and are difficult to see. Jupiter's magnetic field is the strongest of any planet in the solar system, about 20,000 times stronger than Earth's. This powerful magnetosphere traps charged particles and creates intense radiation belts around the planet. Jupiter has 95 known moons and counting, forming a miniature solar system of its own. The four largest moons, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, are fascinating worlds in their own right. Europa, in particular, is of great interest to scientists because it may harbor a subsurface ocean beneath its icy crust, potentially capable of supporting life. Despite its turbulent atmosphere and extreme conditions, Jupiter has been a target for exploration. NASA's Juno spacecraft is currently studying the planet, providing valuable insights into its composition, gravity field, magnetic field, and polar magnetosphere. So as we look at Jupiter, we see a planet of extremes, as it is the largest, fastest spinning, and home to the most powerful storm in the solar system. It's a giant that continues to captivate our imagination. Our next stop is Saturn, the sixth planet from the Sun, and the second largest in our solar system. Saturn is a gas giant, composed mostly of hydrogen and helium, much like Jupiter, but what truly sets Saturn apart is its stunning ring system. These rings are made up of countless ice and rock particles, ranging in size from tiny grains to massive chunks the size of mountains, and they extend up to 282,000 kilometers, or 170,000 miles in diameter. Saturn's rings are not a single solid structure, but are divided into 7 main rings, with gaps and divisions between them. The most prominent gap is the Cassini division, a 4,800 kilometer wide or 3,000 mile wide region between the A and B rings. Saturn has the most moons of any planet in our solar system, with 146 confirmed moons and counting. These moons range from tiny moonlets to the massive Titan, which is larger than the planet Mercury. Titan, Saturn's largest moon, is a world of its own. It has a thick atmosphere, primarily composed of nitrogen, and lakes and rivers of liquid methane and ethane. Titan is one of the few places in the solar system where we see clear evidence of stable bodies of surface liquid. Another fascinating moon is Enceladus, which has geysers that spew water ice and organic molecules from an underground ocean beneath its icy crust. These plumes suggest that Enceladus might have the conditions necessary for life as we know it. Saturn's atmosphere is a turbulent place, with winds reaching speeds of up to 1,800 kilometers per hour, or 1,100 miles per hour. One of the most intriguing features in Saturn's atmosphere is the hexagon-shaped storm at its north pole, a phenomenon not seen anywhere else in the solar system. This massive storm is larger than Earth, measuring roughly 32,187 kilometers, or 20,000 miles across, with winds that can reach 500 kilometers per hour, or 300 miles per hour. Despite its size, Saturn is the least dense of all the planets. It is believed that Saturn would float if placed in a large enough body of water. This low density is due to its composition, primarily hydrogen and helium. So as we look at Saturn, we see a planet of breathtaking beauty and complexity, with its iconic rings, numerous moons, and dynamic atmosphere. Our next stop is Uranus, the seventh planet from the Sun, and one of the most unique worlds in our solar system. Uranus is an ice giant, composed mainly of icy materials like water, ammonia, and methane, surrounding a small rocky core. This gives Uranus its characteristic blue-green color, as methane absorbs red light and reflects blue light back into space. One of the most fascinating aspects of Uranus is its extreme axial tilt. Uranus rotates on its side with an axial tilt of about 98 degrees. This unusual tilt is likely the result of a collision with a planet-sized object long ago. As a result, Uranus experiences the most extreme seasons in the solar system, with each pole getting around 21 years of continuous sunlight, followed by 21 years of darkness. Uranus has a faint ring system, consisting of 13 known rings. These rings are much darker and narrower than Saturn's, composed mainly of large particles and dust. Uranus has 28 known moons, named after characters from the works of William Shakespeare and Alexander Pope. The 5 largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are icy worlds with varied and complex surfaces. Miranda in particular is notable for its extreme geological features, including giant canyons and cliffs. A day on Uranus is relatively short, lasting about 17 hours. However, a year on Uranus is quite long, taking about 84 Earth years to complete one orbit around the Sun. Uranus was the first planet discovered with the aid of a telescope. It was discovered by astronomer William Herschel in 1781, although he initially thought it was a comet or a star. Despite its distance from the Sun, Uranus has a surprisingly dynamic atmosphere. It's a very cold and windy world, with wind speeds reaching up to 900 kilometers per hour, or 560 miles per hour. The planet's atmosphere is composed mainly of hydrogen and helium, with a small amount of methane. So as we look at Uranus, we see a planet of unique characteristics, tilted on its side, with extreme seasons, faint rings, and a dynamic atmosphere. Our next and final stop is Neptune, the 8th and most distant planet from the Sun in our solar system. Neptune is an ice giant, similar to Uranus, composed mainly of hydrogen, helium, and methane. This methane gives Neptune its slightly darker blue color, as it absorbs red light and reflects blue light back into space. One of the most fascinating aspects of Neptune is its supersonic winds. Neptune has the fastest winds in the solar system, reaching speeds over 2,000 kilometers per hour, or 1,243 miles per hour. These winds create massive storms, including the Great Dark Spot, a storm similar to Jupiter's Great Red Spot, but it has appeared and disappeared over time. Neptune has a faint ring system consisting of 6 known rings. These rings are made of dust particles and ice, and they are much darker and narrower than Saturn's rings. Neptune has 16 known moons, with Triton being the largest. Triton is a fascinating world, with geysers that spew nitrogen gas, indicating active geological processes. Triton orbits Neptune in the opposite direction of the planet's rotation, suggesting it may have been captured from the Kuiper Belt by Neptune's gravity. A day on Neptune is also quite short, lasting about 16 hours. However, a year on Neptune is incredibly long, taking about 165 Earth years to complete one orbit around the Sun. This means that since its discovery in 1846, Neptune has only completed one full orbit. Neptune was the first planet located through mathematical predictions rather than direct observations. French astronomer Urbain Le Verrier predicted its position based on disturbances in Uranus's orbit, and German astronomer Johann Galle confirmed its existence in 1846. Neptune also has a dynamic atmosphere with large storms and high-speed winds. The planet's atmosphere is composed mainly of hydrogen, helium, and methane, with the methane giving it its blue hue. So as we look at Neptune, we see a planet of supersonic winds, dynamic storms, and a stunning blue color. It's a distant world that continues to intrigue scientists and expand our understanding of the solar system. As we conclude our journey through the solar system, we've uncovered fascinating facts about each planet. We've seen Mercury's extreme temperatures and surprising ice deposits, Venus's runaway greenhouse effect and volcanic landscapes, Earth's water and life-covered surface, and Mars's towering volcanoes and ancient river valleys. We've marveled at Jupiter's great red spot and turbulent atmosphere, Saturn's iconic rings and its many moons, Uranus's unique tilt and extreme seasons, and Neptune's supersonic winds and mysterious storms. Each planet, with its unique characteristics and mysteries, contributes to the rich tapestry of our solar system. These celestial bodies not only captivate our imagination, but also deepen our understanding of the universe and our place within it. Thank you so much for joining me on this journey. I hope you enjoyed it and learned something new. If you did, feel free to show your support with a thumbs up or by sharing this video with other curious minds. Your support truly helps a great deal. I would also love to hear your thoughts on our solar system in the comments below, or let me know your favorite planet. If you would like to join me on more adventures like this in the near future, feel free to subscribe. Thanks again. Until next time, take care and be well.